Hello everyone, I am Rafia. I am currently pursuing BTech in SRET from CAT department. Now I am going to present a topic about directional derivative and angle between two surfaces with examples. Directional derivative and angle between two surfaces. Introduction. In multivariable calculus, understanding how functions change in different direction is essential. To the directional derivative extends the concept of partial derivatives, allowing us to measure the rate of change of a function in any specified direction, not just along coordinate axis. When two surfaces intersect, they form a curve and create an angle at their intersection. Understanding this angle has practical applications in engineering physics and computer graphics. Concepts build the foundation for optimization, surface analysis, and geometric modeling. Directional derivative definitions. Directional derivative measures the rate of change of a function f of x, y in any specified direction, not just along the coordinate axis. Formula for directional derivative. Directional derivative of f in the direction of u is equals to del f into u, where del f is the gradient vector and u is a unit vector pointing in the desired direction. Key components. Gradient del f is equals to dou f by dou x, dou f by dou y gives direction of steepest ascent. The unit vector u is equals to cos theta comma sin theta specifies the direction of interest. Gradient vector definition. The gradient of f of x comma y comma z is del f is equals to dou f by dou x, dou f by dou y, dou f by dou z. Vector of all partial derivatives points in direction of steepest ascent notation del f or grad f. Key properties. Direction points towards maximum rate of increase of f, magnitude modulus of del f equals the maximum rate of change perpendicular to level curves or surfaces. Zero gradient indicates critical point. Example for directional derivative. Given f of x comma y is equals to x square plus y, x square y plus y cube. Now we have to find that the directional derivative at 2 comma 1 in direction of v is equals to 3 comma 4. Here step 1 we have to find the partial derivatives, and the second step we have to find the derivative at point 2 comma 1. Here the step 3 we have to find the unit vector, and in step 4 we have to calculate the directional derivative by applying the formula directional derivative of f in the directional derivative of u. Here the angle between two surfaces. When angle between two surfaces intersect, they form an angle at their curve of intersection. T is an angle is determined by the normal vectors to each surface at the point of intersection. The normal vector is perpendicular to the tangent plane of a surface at any given point. Geometric interpretation. Imagine two planes touching at a point. The angle between the surfaces equals the angle between their normal vectors. If normals point in similar directions, the angle is small. If they point in opposite directions, surfaces meet at a steep angle. Formula for angle between two surfaces. The angle theta between two surfaces, capital F of x comma y comma z and capital G of x comma y comma z is equals to 0 at a point of intersection is found using the gradient vectors of both surfaces. Formula for angle between two surfaces. Cos theta is equals to del f into del g divided by modulus of del g into modulus of del g, where del f and del g are the gradient vectors evaluated at the point of intersection. The angle between surfaces equals the angle between their normal vectors gradients when cos theta is equals to 0. The surfaces are orthogonal perpendicular. Example for angle between two surfaces. Find the angle between surfaces x square plus y square plus z square is equals to 9 and z is equals to x square plus y square minus 3 at point 2 comma 1 comma 2. Here now we have to find that capital F is equals to x square plus y square plus z square minus 9. Del F is equals to 2x 2y 2z. At 2 comma 1 comma 2, del f1 is equals to 4 comma 2 comma 4. Here surface is capital G is equals to x square plus y square minus z minus 3. Del G is equals to 2x comma 2y comma minus 1. At 2 comma 1 comma 2, del g2 is equals to 4 comma 2 comma minus 1. Cos theta is equals to modulus of del f1 into del g2 divided by del g1, del f1 and del g2. 16 plus 4, modulus of 16 plus 4 minus 4 into 6 into square root of 2 1. Here 16 divided by 6 root 1, 6 root 21 is equals to 0.582. Theta is similar to 54.4 degrees. Applications of directional derivatives. Physics. In physics, heat is between analysis is along surfaces, fluid dynamics modeling in electromagnetic field calculations, and temperature gradient studies in thermodynamics. Engineering. Surface design optimization, structural analysis, aerodynamic space optimization, and calculating rates of change in manufacturing processes. Computer graphics, surface rendering and shading, normal mapping for realistic lighting, terrain generation, and calculating surface orientations for 3D modeling. Thank you for giving me this opportunity.